This video provides guidelines, recommended practices, and other information for the safe handling and unloading of caustic tank cars and tank trucks. It represents a compilation of current experience and knowledge drawn from Chlorine Institute members. While this video covers the safe handling of caustic soda and caustic potash, it is intended to be supplemental to your employee training programs. Further information can be obtained from Chlorine Institute pamphlets. Pamphlet 65, Personal Protective Equipment for Chloralkali Chemicals. Pamphlets 80, 87, and 88, Recommended Practices for Handling Sodium Hydroxide Solution and Potassium Hydroxide Solution for Caustic Barges, Tank Cars, and Cargo Tanks. Pamphlet 94, Sodium Hydroxide Solution and Potassium Hydroxide Solution for Caustic Storage Equipment and Piping Systems. Pamphlet 164, Reactivity and Compatibility of Chlorine and Sodium Hydroxide with Various Materials. And the video, Preventing Non-Accident Releases by Properly Securing Caustic Tank Cars. Topics to be covered by this training video include basic properties and uses of sodium hydroxide and potassium hydroxide, personal protective equipment, safety equipment and first aid, acceptable materials of construction, spill control and mitigation, and tank car and tank truck unloading procedures. Sodium hydroxide, also known as caustic, caustic soda, NaOH, lye, soda lye, and sodium hydrate, is one of the largest volume chemicals produced and consumed. Potassium hydroxide is also known as caustic potash, caustic, KOH, potash lye, soda lye, and potassium hydrate. Unless otherwise stated, the name caustic will be used to refer to both caustic soda and caustic potash during this video. Other containers and shipment methods for caustic, including barges, totes and IBCs, and drums, will not be covered by this training video. Caustic plays an important role in the manufacturing of thousands of products we depend on every day, such as soaps and detergents, rayon and other textile products, cellophane, paper, and cleansers. Common household products, such as drain cleaners and oven cleaners, usually contain either sodium hydroxide or potassium hydroxide. Potassium hydroxide is found in varied items such as liquid soaps, lotions, shampoos, hairsprays, and denture cleaners. Sodium hydroxide is a strong inorganic base. It is a clear to cloudy solution. It leaves a white residue when dried. Caustic will also react, sometimes violently, with low pH materials. Mixing strong acids, for instance hydrochloric acid, with caustic will generate large quantities of heat, causing the mixture to splatter. Water reacts with caustic soda. The reaction will be exothermic, where heat will be released. So for safety purposes, always add caustic to water. Caustic solutions are highly corrosive and need to be handled carefully. Contact with eyes or skin can cause severe burns. You may not initially feel caustic when your skin is exposed, so be sure to wash any potentially affected areas. Like most chemicals, caustic can be shipped and stored safely if proper procedures are followed and personal protective equipment is used. Always follow your company's PPE procedures. The recommended safety equipment when working around caustic solutions is based on the activity being performed. Your facility may have performed a job safety analysis of specific tasks and may recommend a different level of PPE. Such different levels of PPE are compatible with the purpose and intent of the recommendations in this video. When unloading and loading shipping containers or performing initial line breaks, chemical protective gloves, a full-face shield and splash goggles, protective hood or hat, chemical protective boots, and a chemical protective suit should be worn. Your company's air testing results and policy will dictate whether a respirator is required for any or all of these activities. Refer to Pamphlet 65 for more details. For material sampling, A face shield, splash goggles, and chemical protective gloves should be worn. For emergency response, chemical protective hood or hat, face shield and splash goggles, chemical protective suit, chemical protective gloves, and chemical protective boots should be worn. In severe cases with spraying caustic and a major leak, SCBA or full-face air supply respirator with an auxiliary self-contained air supply should be worn. In less severe cases, such as a leaking valve or pipeline with no appreciable spraying and/or splashing product, respiratory protection may not be needed. This recommendation is based on the assumption that, unless otherwise determined by the incident commander, the responders to such as sodium or potassium hydroxide release will not be exposed to concentrations in excess of 2 mg per cubic meter in any 15-minute period. It is very important that chemical goggles are always worn, even when using a face shield. There is a natural tendency to turn the head quickly when sprayed in the face, exposing the side of the face and eyes if not protected. The chemical protective suit should be worn with the jacket buttoned to the neck, sleeves on the outside of rubber gloves, and trouser legs on the outside of chemical-resistant rubber boots. The trouser legs are put on the outside so that if the wearer is splashed with caustic, the caustic will flow down the suit onto the ground and not get trapped inside the boot. This prevents chemical burns to the feet. A NIOSH-approved full-face respirator with high-efficiency particulate filters should be worn when dust or mist concentrations exceed the permissible exposure limit of 2 mg per million. A positive pressure self-contained breathing apparatus, or SCBA, is recommended in emergency response situations that involve exposure to unknown or immediately dangerous to life and health (IDLH) concentrations of caustic. Where caustic solutions are being sampled and/or handled at temperatures above 120 degrees Fahrenheit, PPE for thermal protection may be necessary in addition to any chemical-resistant PPE used. Contact a safety supply provider or a PPE manufacturer for proper PPE selection. Use of protective equipment reduces the possibility for exposure. However, there are other precautions that can be taken to reduce the likelihood of injury should an exposure occur. Safety showers and eye wash fountains that are readily available, clearly marked and operational in all areas where caustic is being handled, will provide for quick irrigation of skin or eyes exposed to caustic. Safety showers and eye wash fountains should be checked for proper operation before beginning caustic handling activities. Users should also consult the latest ANSI standard Z358.1, which outlines additional criteria in the safe use of safety showers. Topics covered include safe design, placement, water temperature, and inspection procedures. These showers and fountains should have a potable water supply system capable of supplying tempered water. Consideration should be given to providing alarms on safety shower handles to automatically alert other personnel to the emergency. Following precautionary procedures can mean the difference between safety and injury. Sometimes even a well-trained and well-protected operator can accidentally be exposed to caustic. Proper training in first aid procedures is important when working with caustic solutions. There are 3 important points to remember when dealing with caustic solution exposure: speed, water, and medical attention. The sooner caustic is flushed off the skin or out of the eyes with water, the less chance of a chemical burn or permanent vision damage. If your eyes are exposed to a caustic solution, quickly get to an eye wash fountain. Every second counts. Begin flushing your eyes immediately. Once your hands are washed and free of any possible material, use your fingers to hold your eyelids open. This will allow water to flush any caustic solution that is inside the eyelids. Rinse your eyes uninterrupted for at least 15 minutes and then continue washing until directed to stop by responding medical personnel. If your skin, hair, or clothing is exposed to caustic, quickly get to a safety shower. Keep goggles on and hold them tightly to your face unless the eyes have also been exposed. Goggles prevent caustic on the hair from washing into the eyes. Remove clothing as soon as possible while showering. Forget modesty. You must remove contaminated clothing to prevent injury. After washing your hair, face, and hands, remove the goggles. Continue showering for at least 15 minutes or as specified in the SDS. When personnel have been exposed to caustic solutions, additional medical treatment may be necessary. Never attempt to neutralize the caustic. Neutralization is an exothermic reaction that produces heat and can cause thermal burns as well as chemical burns. Do not apply oils or ointments to burns without specific instructions from medical personnel. When necessary, the victim should be moved to a medical facility immediately following prescribed washing. In the case of caustic mists or aerosol inhalation, quickly move the victim into fresh air and consult medical personnel. If caustic is accidentally swallowed, drink large quantities of water and contact a physician. Do not induce vomiting. Much of the information presented here is contained in the Safety Data Sheet, more commonly known as an SDS. This sheet is available from the sodium hydroxide or potassium hydroxide supplier and should be studied and understood. Keep a copy readily available for review. It's also valuable to send a copy of the SDS with the victim when transported, as a quick reference for medical personnel. The guidelines in this section are intended to provide sound engineering practices for the design, fabrication, operation, and maintenance of above-ground caustic storage tanks. Please reference pamphlet 94 for additional information. The most common material for tank construction is carbon steel for 50% caustic storage tanks maintained below 120 degrees Fahrenheit. Storage tanks constructed of carbon steel can be protected with the application of various lining or coating systems. The success of the liners is typically a function of temperature. There is a wide range of liners in service that include various rubbers, coating systems, metal cladding, and thermoplastic linings. Materials such as PVC, CPVC, polypropylene, polysulfone, and the fluorocarbon resins PFA, FEP, PTFE, and ECTFE will normally not be degraded by 50% caustic soda. Plastic tanks and liners can fail if maximum temperatures are exceeded. Therefore, design should take into consideration the maximum process temperature. Many plastics like polyethylene and FRP fabricated storage tanks have been used for small tank storage applications. It is important the tank be designed with sufficient structural strength for the caustic stored. The specific gravity of most caustic solutions at an ambient temperature of 20 degrees centigrade is approximately 1.5. Please reference pamphlet 94, Appendix A, for additional information on specific gravity. It is important the tank be maintained above caustic freezing temperatures without the use of high-temperature heating devices, which can weaken plastic materials at elevated temperatures. As the temperature increases, caustic becomes more corrosive to many metals. Above 120 degrees Fahrenheit, more corrosive-resistant materials such as alloys of nickel should be considered due to stress corrosion cracking. Stainless steel has been used up to 200 degrees Fahrenheit. Nickel or nickel alloys are used at temperatures above 200 degrees Fahrenheit. Higher temperature storage requires special materials of construction. Reference pamphlet 94 for additional information regarding materials of construction. Carbon steel storage tank linings are used for corrosion resistance or where low iron product quality is important. Linings used include plastics like PVC and polypropylene. Rubber linings and epoxy coating systems are also used. Caustic is highly reactive with some metals, including aluminum, tin, and zinc, while also generating flammable hydrogen gas. Diluting caustic will generate heat. Cooling may be required to maintain the integrity of the equipment. Positive mixing devices like agitators or inline mixers should be used to prevent layering of higher caustic concentrations at the bottom of the tanks. Common clothing materials, such as leather and wool, and to a lesser extent cotton and linen fabrics, can be destroyed by caustic. 50% sodium hydroxide solution freezes below 58 degrees Fahrenheit, while 45% potassium hydroxide solution freezes at -27 Fahrenheit, that's -33 degrees Celsius, and 50% potassium hydroxide solution freezes at 36 degrees Fahrenheit or 2 degrees Celsius. 50% caustic should be stored in a heated building or in heated equipment. Frozen caustic may be difficult to return to a liquid state and will require additional heat. Outdoor storage tanks are insulated and heated with steam or electric heaters to keep the caustic from freezing. Heating elements are often nickel or nickel alloy to prevent corrosion at the heating interface. Heating of the tank wall can also be accomplished with steam coils or electrical heating tape. Wall heating systems must be designed to avoid the creation of localized hotspots, which can exceed the design limits of the tank or vessel. Self-limiting heat trace and insulation is used to prevent 50% caustic from freezing in outdoor piping systems. Welded carbon steel piping systems are commonly used. Stainless steel and nickel or nickel alloys are used for higher temperature piping applications. Refer to CI Pamphlet 94 for additional information on caustic piping systems. Suitable gasket materials for flange piping and equipment include PTFE, EPDM, graphite, or filled PTFE. Ball, plug, butterfly, and gate valves are used in caustic service. Ensure the body and sealing materials are compatible at the system's operating temperature. Aluminum, magnesium, zinc, brass, copper, and tantalum are materials that are attacked by caustic and must be avoided. Caustic tanks are normally vented to atmosphere. Never cover a vent used to protect against tank failure due to overpressure or vacuum. Ensure that the vent size is appropriate for the tank's operation. Liquid caustic can sometimes freeze in and plug tank vents, where mist carryover exists in climates below 58 degrees Fahrenheit. Ensure tank vents are maintained clear from restrictions due to caustic buildup. Level instrumentation should be provided to prevent overfilling tanks. An overflow pipe directing caustic to a safe location at grade should be provided in the event the tank is overfilled. The capacity of the storage tanks should be at least 1.5 times the size of your largest shipment volume. Always ensure there is enough available space in the storage tank for the tank car or tank truck contents before unloading. It is recommended that tanks should be located inside diked containment areas that can hold the entire content of the tank. Check your local authority having jurisdiction for your containment requirements. Spills of caustic should drain to a collection sump to allow for safe collection and disposal. Unloading pipes should be clearly labeled with the proper solution. If you are unloading sodium hydroxide, the pipes should be labeled with UN 1824 or sodium hydroxide solution or caustic soda, or any combination of these indicators. If you are unloading potassium hydroxide, pipes should be labeled with any combination of UN 1814 or potassium hydroxide solution. It is critically important to prevent the mixing of incompatible chemicals, such as acids, with caustic solutions. Verify that the chemical name on the bill of lading matches the name of the chemical in the tank and piping prior to unloading. Proper maintenance of all caustic piping systems is important. All leaks should be isolated and repaired as soon as possible to minimize potential worker exposure. Caustic tank cars are commonly 16,300-gallon capacity, constructed of carbon steel with an epoxy liner. They have an external steam coil, insulation, and a jacket, so that the caustic can be thawed before offloading. Caustic tank trucks typically have a capacity between 3,000 and 6,000 gallons. Although not specifically required by the regulations, many caustic cargo tanks are insulated. The most common insulation systems are urethane foam or fiberglass with a metal jacket. Insulated cargo tanks are commonly used for shipments where ambient temperatures could reduce the caustic temperature below the freezing point. Only chemical hoses designed specifically for caustic should be used for loading and unloading. Consult your chemical hose manufacturer for proper hose selection. Never use hoses with aluminum fittings. Even when operators attempt to follow approved methods and procedures, spills and releases may occur. The amount of caustic and the circumstances surrounding the release or spill dictate the reporting requirements. Releases or spills must be reported according to federal, state, provincial, and local government regulations. For transportation-related incidents within the United States, Chemtrec should be notified. In Canada, the local provincial authority, usually the local police, must be notified immediately, and in the case of a railway incident, Canutech must also be notified. Chemtrec and Canutech both provide immediate advice for those at the scene of the incident. Chemtrec will also promptly contact the shipper and others as required. The EPA reportable quantity for sodium and potassium hydroxide is currently 1,000 pounds as 100% concentration. If the quantity of sodium hydroxide or potassium hydroxide in a release during any 24-hour period is 1,000 pounds or greater as 100%, the National Response Center must be notified immediately. Specific reporting requirements should be detailed in your facility's spill control or emergency response plan. All transportation releases, no matter the quantity, require reporting to DOT. Basically, if you can see it, smell it, or hear it during transportation functions, it requires reporting to DOT. Check with state and local agencies for additional reporting requirements. Documentation of the incident is important. You should expect to supply the following information. What is the name of the chemical spilled? In this case, it's either sodium hydroxide or potassium hydroxide. What was the estimated quantity released? What was the time and duration of the release? What are the surroundings into which caustic was released? What are the anticipated acute or chronic health effects, and what are the proper precautions that should be taken? This information can be obtained from the safety data sheet. Containment of a leak is extremely important. Whenever practical, a dike should be constructed to contain the spill. When the spilled material is unrecoverable, it can be carefully neutralized with a weak acid, such as acetic acid. Caustic should never be flushed to a sanitary sewer or other outlet which connects to waterways or uncontrolled runoff streams. Cleanup and waste disposal must conform to applicable permits and current hazardous waste regulations. Any site handling caustic should have a written emergency response plan in the event a spill or leak occurs. Only trained and qualified operators wearing proper protective equipment should be involved in the unloading process. The operator should be familiar with all fittings, including the pressure relief device, caustic transfer line, and their parts, and follow written procedures. This video covers the delivery of caustic by tank car and by tank truck. It is important to comply with the specific facility requirements at all times. CI recommends the use of pre- and post-loading and unloading checklists when transferring from tank cars or tank trucks, such as those provided in CI pamphlets 87 and 88. Caustic loading or unloading facility design should consider the need for the following equipment: a platform or ramp to access the top of the tank car or tank truck, safety showers and eye wash protection located at ground and platform levels, loading arms with a device to prevent movement during transfer, transfer hoses compatible with caustic, level, temperature, and flow instrumentation with control and/or auto closure valves, utilities including steam, compressed air, and water supply, accessibility, vehicle clearance and communication requirements, ergonomic and fall protection considerations, and sampling requirements. The unloading area for both tank cars and tank trucks should be constructed so that any spillage that occurs will be properly contained for recovery or disposal. Emergency showers and eye wash facilities should be located close to the unloading operation and should be checked for proper operation prior to unloading. Special attention must be given to lighting in the area since adequate lighting is needed for safe nighttime operation. Even if night operations are not contemplated, effective lighting should be installed as an aid in dealing with possible nighttime emergencies. Emergency lighting should be available in case of a power failure. Both tank cars and tank trucks are required to be protected from accidental movement during unloading. In securing a tank car from movement prior to unloading, it is important to spot the tank car, set the handbrake, chock the wheels, and set the derails. A caution sign must be provided for the open end or ends of the siding. Caution signs are placed near each derailleur and in front of and behind the tank car to warn persons approaching the car it is positioned for unloading. Caution signs must remain in place until unloading is complete, the connections are removed, and the valve outlets are properly closed. Blue lights or flags or red flashing lights can be used in conjunction with caution signs to warn of unloading operations. See DOT Regulation 49 CFR 174.67 and 49 CFR 173.31. In securing a tank truck from movement prior to unloading, it is important to spot the tank truck on level ground, set the handbrake, shut off the engine if it's not being used for unloading, and chock the wheels. Before accessing the top of a tank truck or tank car, ensure that safety fall protection equipment is in place and functioning properly. Before unloading, verify that the contents of the tank car or tank truck is sodium hydroxide or potassium hydroxide by careful inspection of the bill of lading or other shipping documents, any man-way tags, the car numbers, commodity marking and placards, and/or sampling. Extreme care should be taken to ensure that the contents are properly identified. An inspection checklist should be used for all aspects of the unloading operation for tank cars. It should include all recommendations contained in Pamphlet 87, plus any company procedures or special requirements specific to the facility. The checklist documents that the proper unloading and securement procedures have been completed, and if required, proper corrective actions have been taken. Tank cars or tank trucks are equipped with either a rupture disc or a pressure relief valve, sometimes called a PRV. Neither device should be tampered with or removed by the customer. If either of these devices leak, take appropriate action per your emergency response plan and notify the product supplier. Caustic is typically shipped in insulated tank cars and usually arrives ready to unload. Delays in shipments or very cold weather may cause the caustic to freeze and require the caustic to be steam heated before unloading. Heating the tank car with low-pressure steam, less than 15 psig, through the external coils will thaw the frozen caustic sufficiently to allow the caustic to be unloaded. The steam source at the unloading station must be regulated from line pressure, usually 100 to 125 psig, down to a supply pressure of 15 psig to prevent hot steam from damaging the tank car's interior coating or the tank car. A steam line, hose or piping or both is attached to one of the two pipe nipples on the tank car. A steam trap is connected to the other opening on the tank car's steam coils, and the trap discharge is connected to the condensate return system. The use of a properly sized and properly operating steam trap will give the user the fastest melting time for frozen caustic. Frozen caustic in a valve may prevent a valve from opening. A lance connected to a steam hose may be used to apply steam directly to a frozen car valve or inside a tank car for thawing. The steam is regulated to below 15 psig. Thermal protection should be considered to prevent burns from hot steam assemblies, and appropriate PPE should be considered to prevent caustic exposure from splatter. After venting off any pressure and opening the top manway, a product sample can be taken using a collection cup attached to an extension rod. After sampling, ensure that the container and sampling equipment is well rinsed to remove any caustic residue. Close the manway hatch prior to unloading a tank car or truck with pressurized air. It generally takes around 3 hours to unload a tank car and about 30 to 60 minutes to unload a tank truck. Actual time will vary based on line size and pressure. Throughout the entire unloading process, the operation should be continuously monitored. For tank cars, although not required by regulation other than for transloading operations, it is strongly recommended to provide continuous monitoring consistent with DOT regulations for transloading. This can be done by either a designated hazmat employee who is physically present or by a remote monitoring and signaling system that is observed by a hazmat employee. For tank trucks, continuous monitoring can include a person attending at the unloading station, the use of surveillance systems with remote controls, or hoses equipped with auto-closing valves. Any signaling system should provide immediate notification of any system malfunction or other emergency to allow immediate corrective actions to be taken as necessary. Pamphlets 87 and 88 have detailed discussions on monitoring practices. If it is necessary to discontinue unloading a tank car for any reason, all valves should be tightly closed to stop the flow of caustic. Unloading connections should be disconnected, and plugs should be installed in the tank car valves. There are two methods primarily used for unloading tank cars: pumping caustic from the car's bottom valve to the storage tank, and pressurizing the tank car with compressed air to push the caustic to the storage tank through the car's eduction pipe. For pump unloading of a tank car, caustic is transferred using a pump from the bottom fitting of the tank car to a storage tank. Refer to CI Pamphlet 87, Figure 9.1 for proper unloading assembly. For bottom pump unloading of a tank car, the following actions are performed. The manway is propped open for venting purposes and to prevent the potential of collapsing a tank car. Ensure the bottom outlet valve is closed and carefully remove the plug from the outlet fitting underneath the car. Install the unloading hose assembly to the outlet valve beneath the car and close the steam valve. Open the transfer piping valves from the pump to the storage tank. Open the bottom valve on the tank car. Check for leaks. Start the pumps and again check for leaks. If leaks are found, close the valves, drain and repair the leaks as necessary. Unload the contents of the tank car to the designated storage tank. There are several different types of outlet valves, including internal valves operated from the top of the car, internal valves operated from the bottom of the car, and external valves operated from the bottom of the car. In an effort to further reduce the potential for accidental releases from bottom outlet valves in derailments, the rail industry has innovated new bottom outlet valve (BOV) handles. The intent of the new designs is to avoid accidental engagement and opening of the valve during transportation. These handles may be stowed separately, located completely within the skid, or disengaged from the valve when in the closed position. When the caustic tank car has been unloaded, verify that the car is empty by shining a light into the open manway. Close all tank car valves. Then blow the lines clear with steam. Close all pump station valves and remove the unloading hose assembly. Secure all tank car fittings even if they are not used during unloading. Product transfer through the top outlet can be accomplished by gas padding. The caustic is transferred out of an eduction pipe inside the tank car to a storage tank. Refer to CI pamphlet 87, figure 9.2 for top unloading with the gas pad. Check to make sure the storage tanks are adequately vented before unloading using air pressure. For pressurized unloading of a tank car, the following actions are performed. Ensure that the tank car valves are closed. Open the valve housing cover and remove the seal cables. Open the air valve to ensure there is no pressure in the tank car. Connect the flexible unloading hose to the eduction pipe outlet valve. If a retain sample was taken, close and tighten the manway so the gasket seals properly. Attach the compressed air manifold to the tank car air valve. Slowly open the compressed air valve to increase the pressure into the tank car up to 25 psig. Slowly open the eduction pipe outlet valve to flow the caustic soda to the storage tank. Check for leaks and shut down the unloading process for repair if necessary. The sound of rushing air or a drop in pressure can indicate that the tank car is empty. The compressed air supply manifold includes a pressure regulator and pressure gauge to monitor the air pressure during the unloading and disconnecting. The regulator should be preset so that the air pressure does not exceed 25 psig. When the caustic tank car has been unloaded, close the product transfer line. Close the tank car inlet valve. Close the compressed air supply. Vent the air from the manifold and remove the air manifold. After the air is disconnected, open the air inlet valve to vent any pressure from the tank car. Open the manway hatch to verify that the car is empty by shining a light into the open manway. Drain and remove the unloading hose. Close and seal the manway hatch with the gasket installed. Verify all tank car valves are closed. Cap the tank car piping connections. And secure all tank car fittings even if they are not used during unloading. There are two methods primarily used for unloading tank trucks: pumping caustic from the bottom valve to the storage tank and pressurizing the tank truck with compressed air to push the caustic to the storage tank. The truck's parking brakes must be set and the chocks should be installed. Ensure the truck driver complies with company procedures, including the use of pre- and post-unloading checklists. For pump unloading of a tank truck, caustic is transferred using a pump from the bottom fitting of the truck to a storage tank. Refer to CI Pamphlet 88, Figure 5.2 for a side view of a typical bottom outlet valve arrangement, rear or midway. Caustic may be shipped in an insulated tank truck and usually arrives ready to unload. Delays in shipments or very cold weather may require the caustic to be steam heated before unloading. Heating the tank truck with low-pressure steam through the external coils will thaw frozen caustic sufficiently to allow the caustic to be unloaded. The steam source at the unloading station should be regulated down to a supply pressure of 15 psig to prevent hot steam from damaging the cargo tank and/or its lining. For bottom pump unloading of a tank truck, the following actions are performed. Remove the tamper indicator seal on the dome and bottom valve. The manway is propped open to vent and prevent the potential of collapsing a tank truck during unloading. Connect the unloading hose from the unloading valve to the unloading pump. Use the hydraulic hand pump to open the internal unloading valve if present. Then open the external unloading valve. Start the pump. Check for leaks and repair as necessary. For pressurized unloading of a tank truck using pressurized air, obtain a retain sample if needed, then securely close the dome cover. Remove the tamper indicator seals and cap from the bottom unloading valve. Connect the unloading hose to the truck outlet connection. Connect the unloading hose to the tank connection point. Connect the compressed air hose to the tanker's air connection. Most tank trucks have their air connection below, at fender level, like this example, but some may have their air connection on top. Ensure the source of the air has a pressure regulator set to no more than 25 psig. Slowly open the truck internal and external bottom valves to initiate the caustic flow to the tank. Check for leaks. If there are any leaks, close the valves and correct the source of the leak. Slowly open the air valve to pressurize the tank truck to about 15 to 20 psig. Do not exceed 25 psig. The sound of rushing air or a drop in pressure can indicate that the tank truck is empty and that the transfer is complete. Close the unloading line valve, if any, and the external valve on the tanker as soon as possible. Close the truck's internal and external valves. Bleed off the air pressure in the truck using a top opening before leaving the unloading area. Relieve the pressure from the transfer line and then carefully remove the loading hose away from your person. Replace the outlet caps, secure the dome lid, and close all valves. At the completion of any unloading process, wash any caustic spillage from the tank cars or tank trucks and other equipment to protect personnel who may handle the car and to prevent corrosion. Wash out the hoses and process connections if subject to leaking. Wash water should be collected through a suitable collection system and disposed of in a manner that complies with state and federal regulations. Replace any damaged, faded, or missing placards from the tank car or tank truck prior to releasing for transport under DOT regulations. Prior to releasing tank cars, follow the post-unloading checklist guidelines from CI Pamphlet 87. Verify that the tank car manway lid and gasket is secure and sealed, and that tank valves are securely closed. Check to verify that hoses, fall protection devices, tools, and access ramps have been removed from the tank car. Disable the derailleur and remove the wheel chocks. Remove signage and flags and turn off warning lights prior to releasing the tank car. Record the return seal number on the tank car unloading checklist. A word of warning: DOT regulations and AAR standards require fasteners to be wrench tight and all blind flanges to be secured to the tank car by chain or cable. The Chlorine Institute's video Preventing Non-Accident Releases by Properly Securing Caustic Tank Cars provides details on best practices for properly securing and inspecting the tank car to reduce leaks during transport. Prior to releasing tank trucks, follow the post-unloading inspection checklist guidelines from CI Pamphlet 88. Verify that the tank truck manway lid and gasket is secure and that truck valves are securely closed. Check to verify that hoses, fall protection devices, tools, and access ramps have been removed from the truck. Remove barricades, signage, and chocks prior to releasing the tank truck. 50% sodium hydroxide solution freezes below 58 degrees Fahrenheit. Consider that even heat-traced pipes at the customer's facility may have poorly heated sections that can lead to pipe plugging by frozen caustic. If the pressure required to unload rises above normal, especially during wintertime, the line may be plugged with frozen product. Caustic weighs 50% more than water. Tanks need to be designed for the high specific weight of caustic. Caustic is highly reactive with some metals, including aluminum, tin, and zinc, while generating flammable hydrogen gas. Exposure to caustic may cause severe burns. Flush with water and follow first aid procedures documented on the safety data sheet. When unloading and loading shipping containers or performing initial line breaks, the following equipment should be worn: chemical protective gloves, a full-face shield and splash goggles, protective hood or hat, chemical protective boots, and chemical protective suit. Before unloading, check the operation of safety showers and eye wash stations. There are 3 important points to remember when dealing with caustic solution exposure. Speed. The sooner caustic is flushed off the skin or out of the eyes with water, the less chance of a chemical burn or permanent vision damage. Water. Flush with water for at least 15 to 20 minutes. Additional flushing may be required. Please refer to the SDS. And obtain medical attention. If your eyes are exposed to a caustic solution, quickly get to an eye wash station. Every second counts. Begin flushing your eyes immediately. Once your hands are washed and free of any possible material, use your fingers to hold your eyelids open. This will allow water to flush any caustic solution that is inside of the eyelids. Rinse your eyes uninterrupted for at least 15 minutes, and then continue washing until directed to stop by responding medical personnel. The information provided is an overview of CI pamphlet recommendations for safe unloading of product. We recommend that you fully review CI pamphlets 87, 88, and 94 to become familiar with specific recommendations for your site prior to handling caustic. The information contained in this video is drawn from sources believed to be reliable. The Institute and its members, jointly and severally, make no guarantee and assume no liability in connection with any of this information. Moreover, it should not be assumed that every acceptable procedure is included or that special circumstances may not warrant modified or additional procedures. The user should be aware that changing technology or regulations might require a change in the recommendations herein. Appropriate steps should be taken to ensure that the information is current when used. These suggestions should not be confused with federal, state, provincial, municipal, or insurance requirements, or with national fire, building, or safety codes. The Chlorine Institute exists to support the chlor-alkali industry in advancing safe, secure, environmentally compatible, and sustainable production, distribution, and use of its mission chemicals. CI's mission chemicals include chlorine, sodium and potassium hydroxides, sodium hypochlorite, the distribution of vinyl chloride monomer, VCM, and the distribution and use of hydrogen chloride. Chlorine Institute members are committed to adopting CI's safety and stewardship initiatives, including pamphlets, checklists, and incident sharing that will assist members in achieving measurable improvement. For more information on the Institute's stewardship program, visit CI's website at www.chlorineinstitute.org.